Hey guys, Joe back at it once again with some OCR FSMQ past papers, and today we are doing the June 2013 examination paper. So today marks officially 1 month until the FSMQ 2016 paper, so good luck if you're sitting it. You'll be absolutely fine. Just keep watching the videos and hopefully you find them helpful. Keep revising, working hard, and you'll be fine. But let's get into things. Question 1. Find the gradient of the line L, whose equation is 3x plus 2y equals 7. One of the easiest questions I've actually ever seen on the FSMQ paper. It's rearrange to get that, divide both sides by 2. Your gradient is therefore minus 3/2. So that's just grade C, GCSE, grade B, something like that. Part 2. Find the equation of the line which is perpendicular to L, which passes through the point 3,1. Well, perpendicular means the negative reciprocal gradient, so the new gradient will be 2/3. Y minus b equals mx minus a. Put in the numbers and you get that. Times everybody by 3. Rearrange and you end up with 3y equals 2x minus 3. Not too bad for a start in the question. I'd be very happy with that. Part 2. Find the integers that satisfy the inequality 3x plus 1 in the middle of minus 7 and 12. So, split it into 2, you get 3x plus 1 is greater than minus 7. 3x must be greater than minus 8. X must be greater than minus 8 over 3. Do the other side. You get 3x plus 1 is less than 12. 3x must be less than 11. X must be less than 11 over 3. But the key word here is that we want the integers. So we end up with that interval there, and all the numbers that come in between that are minus 2, minus 1, 0, 1, 2, and 3. So there you go, 4 marks. Question 3, a little bit of a smelly one, this. This year, John is 4 times as old as his son Paul. In 5 years' time, John will only be 3 times as old as Paul. Let the age of Paul now be x years. By forming an equation in x, solving it, find Paul's age now. So, 4x plus 5, because if we let x be now, so we'll say he's 2 years old. So in 5 years' time he'll obviously be 7, and that's 5 on. So that's where this 4x plus 5 comes from, because he's going to be 4 times as old as his son now. So it's going to be 4 times the age, add 5, because we're going 4 years now. In 5 years' time, he's going to be 3x plus 5. So 3 times as old as Paul. So x plus 5 is going to be your 2 plus 5, which is 7. So 3 times that, which is 21, obviously. But we'll expand that. So try and get your head around that. It's a pretty difficult concept to get my head around. So, and explain it in words. Rearranging, you get x equal 10. So there you go. You could do it through trial and error, and you'll get the same answer. Question 4 then, you were given that theta is an acute angle and sin theta equals root 5 on 3. Find the exact value of tan theta, so this is virtually the same question as the first one on the June 2009 paper that we did the other day. So if sin theta equals root 5 on 3, that means what opposite is root 5 and what hypotenuse is 3. So we get that. Through Pythagoras then, we get 2 on that there, because it's going to be the root of 3 squared minus root 5 squared, which is 9 minus 5, which is root 4, which is 2. And a tan theta is an opposite over adjacent, so the exact value is root 5 on 2. So maybe this year's paper might have a similar question, so get your head around that. Exact value, by the way, does not mean full calculator display. It means the fractional value of tan theta. Number 5 then, use calculus to find the stationary points on the curve y equals that. So to find a stationary point, we have to diff it and set it equal to 0. So we diff it and then set that equal to 0. I see a common factor of 3 there, so I divide throughout by 3. And then I factorise that to x minus 2, x plus 1. Therefore, my x coordinates must be 2 or minus 1. Therefore, my y coordinates are minus 7 or 13 over 2. So there are your two coordinates there to tell the examiner. Pardon me. Sketch the curve on the axes provided, showing the stationary points and the point where it cuts the y-axis. So you do that. We know that this point there is 3, so just stick a big fat 3 there because of that. And the stationary points are at -1, 6.5. So that's that there. And down here, it's going to be 2, -7. So just tell the examiner what these points are. Just get yourself some more brownie points, really. Question 6 then. Amanda throws 3 fair dice. What is the probability that exactly 2 6s are thrown? So, where x can be binomially distributed, 3, 1/6. P of x equals 2 is 3c2 times success to the 2 times failure to the rest. So that's that, 0.0694. Part 2 then, at least 1 6 is thrown. Well, that's the p of x is greater than or equal to 1, but that's the same as 1 minus p of x equals none. So that's 1 minus 3c0, success to the 0, failure to the rest, which is that, 0.4213. So 6 quick marks in an exam if you can get on top of your binomial distribution. Question 7 then. John and Jenny are asked to draw a triangle ABC with the following properties. AC equals 6, CB equals 4, and angle A equals 40. So John draws the triangle shown in Fig 7.1, and Jenny draws the triangle as shown in 7.2. Calculate the angle B in each case. So, sine rule. Sin x over 6 equals sin 40 over 4. Sin x therefore equals 6 sin 40 over 4. Therefore x equals 74.6. So that must be for this triangle here. And it's going to be 105.4 for this angle here, because remember, if we draw a sine graph, we get that line x equals whatever it was, 6 sin 40, I assume it's up here somewhere. So we get 74.6 there, but we also get another solution at 180 minus that answer, so it's going to be 105.4 there. Question 8 then. A mathematical gardener, don't know what the significance of him being mathematical is, but hey ho, has a garden which is rectangular in shape, measuring 20 metres by 8 metres. He wishes to arrange the garden so that approximately half of it is lawn and the rest is flower bed. He sets up a coordinate system as shown in the diagram below, and maps out the graph of the curve y equals 8x minus x squared. Show that the area of the lawn is approximately 53% of the total area. Now, just before we get into this question, how sad is this guy? Like, honestly, how sad. But anyway, so the area of the rectangle is 8 by 20, length by the width. So that's 160 metres squared, easy peasy. Area under the curve is between 8 and 0, because we know that this is 8 metres wide, and these are the coordinate axes, so that must be 8 there. So it's between 8 and 0 of 8x minus x squared. Add 1 to the power divided by the new power. Stick your 8 in, stick your 0 in, take them off each other, you end up with 256 on 3. Now, the way we're going to check how much of this is shaded, we're going to divide 256 over 3 by 160, because you divide the actual answer by the total and get 0.533333, which is about 53%, which is what the examiner wanted you to do. So not too bad a question. Question 9. Find the values of the constants a and b such that for all values of x equals that. Well, it's completing the square, so you halve the coefficient of x, square it, take off the unwanted square because we only want x squared plus 8x, but we don't want the positive 16 that's going to come out, so we take that away as shown there, and then add 19 on, and we'll get that. Therefore, with a is a 4, with b is a 3. Hence state the least value of x squared plus 8x plus 19 and the value of x at which this occurs. So we need this little bracket to dissolve, and therefore it'll become a maximum point. So the minimum value equals 3 when x equals minus 4. So if this disappears, that's obviously, that x must have been a minus 4, and we're just going to be left with 3. The max value equals a third when x equals minus 4. This is for the third part here, because if you think about it, if we get a min value at 3 when x equals minus 4, if we let the brackety bit disappear again, a better way to explain this perhaps is to say a quarter is less than a third, because if you think about, if you have 1 over the brackety bit, so you've got x plus 4 squared, add 3. Now this here, apart from when it's 0, it's always going to be positive, so that is always going to be greater than a third, and well, less than a third, because a quarter is less than a third, remember. Therefore, the maximum is always going to be a third on that one. So that's another way to think about it, when x equals minus 4, obviously. Question 10 then. One leg of a cross-country race is from A to B. The checkpoint B is at the end of the wall that runs due east-west, as shown in the diagram. So here we go. What bearing should a runner take to travel from A to B, and what is the distance AB? So we want this angle here, and we want the length of this line. So here we go. We're going to get AB first, which is Pythagoras. 1,000 add 2,400, square them and then root them, and you get 2,600 meters. So the angle is going to be opposite over adjacent, which is 2,400 over 1,000, and then shift tan it, and you end up with 067 degrees, because remember bearings, it's 067. Second part, John sets off from A, unable to see the point B. He heads out on a bearing of 055, and when he reaches the wall at point D, he knows he has to go east along the wall to reach B, as shown in the diagram. So AD, this line here, is going to be adjacent over hypotenuse, so it's 1,000 over cos 55. We want the hypotenuse, by the way, so it's adjacent over cos, so you get that. AD must equal that then. So CD, this line here, is going to be 1,000 times sin 55, because it's going to be sin times hypotenuse. Sin. Why is it 1,000? Hold on. 1,000 is that there, and we want that angle there, so that's the opposite. Oh yeah, the opposite equals sin times hypotenuse, so you get that. I'm not entirely sure. It should be 1,000. Not entirely sure that's the case. Hold on. Let's see what I get when I type this in my calculator. So 1,000 times sin 55 is 819.2. Very strange, very strange. I'm not sure I've done that right, because that's the adjacent, isn't it? I'm thinking that should be my answer for here, times sin 55. But I digress. We'll go with the answer. Error carried forward. dB must equal 2,400 minus me previous answer, which is probably not right now I'm thinking about it. So that's there. So if I want to get from B to D, I do the whole line, take away the line I've just worked out. So I get that. So the total distance, therefore, is the AD that I worked out before. Add this here, which I've just worked out, and that equals 3324.2. But check that on the mark scheme. Not entirely sure if that's right. Obviously, the difference between them is 724.2 meters. But now I'm starting to doubt myself on that one. So, question 11. A circle has the equation that, write down the radius of the coordinates and the coordinates of the centre of the circle. So the centre is 2, 0, and the radius is 10, because remember, this bit is r squared, so we just want r, so we square root it. The line y equals 2x plus 6, cuts the circle at 2 points A and B, so we let the y equal 2x plus 6 and we'll square it and add it to x minus 2 squared and set it equal to 100. And we'll get that. See, common factor of 5 there, so I divide through and get that. And then that factorizes to that, and we call it x equals minus 6 or 2. Put that back in, get your y's of minus 6 or 10. So we now want the midpoint of the line that we've just created. So we'll do that, minus 2, 2. Remember, average of the x's, average of the y's. And now the length AB, which is going to be back take back squared, added to front take front squared. So 10 take 6 is 16, and 2 take 6 is 8. So square them and add them, and then root them, and you get 8 root 5. So that is the diameter of the circle, I think. No, it's not a diameter, it's just the length of a line. Hence, find the distance of the centre of the circle from the line AB. So, the length is 2 squared add 4 squared, which is 2 root 5, because the centre of the circle is obviously 2, 0, and the midpoint of the line AB is minus 2, 2. So we do back take back squared, which is going to be 2 squared, added to front take front squared, which is going to be 4 squared, and then we get that there, 2 root 5. Obviously we have to root that. Question 12 then. An object sinks through a thick liquid such that at time t seconds after being released on the surface, the depth s meters is given by that. So find a formula for velocity. The relationship between displacement and velocity is differentiation. So we differentiate s with respect to t, and we get that. Power to the front, not 1 off the power. We want to find the velocity when t equals 4, so we'll let t equal to 4, and it's going to be 32 minus 32, which is 0, so we've shown that it's stopped sinking. Find the acceleration of the object when it's released on the surface of the liquid. So the relationship between velocity and acceleration is differentiation, so we find dv dt, which is 8 minus 4t. Well, let t equals 0, therefore a equals 8. So that's acceleration, that should be an a, just a slight typo there. The greatest depth of the object is going to be when t equals 4, obviously because it stops sinking. So we'll let t equal 4, and s equals 64 minus 128 on 3, which is 64 over 3 meters. On the grids provided, sketch a velocity time and acceleration time graph. So that's where velocity time, and that is what acceleration time graph. So it starts up at 8 here, so that's 8, and it'll end up at, it looks like minus 8, but if we let t equal 4 down here, we'll see that's going to be 8 minus 16, so that's how that works there, and that on the left is a parabola. Question 13 then. A number of students from a group of 20 boys and 30 girls is to be selected to attend a one-day conference. The number of girls attending must be at least the same as the number of boys, but no more than twice the number of boys. So let x be the number of boys and y girls selected. So y is greater than or equal to x because it says it must be at least the same as the number of boys. Therefore y must be greater than or equal to x. But it must also be less than or equal to 2x because it must be no more than twice the number of boys. Y must be less than or equal to 30, obviously, because there's only 30 girls to choose from. And x must be less than or equal to 20, because there's only 20 boys to choose from. So there we go, we'll draw that on like that and shade the regions which were not required. So there's our objective function. In order to attend the conference, the students need to be given a special uniform. The uniform for the boys costs 40 and the uniform for the girls costs 50. The school has 2,000 to spend on the uniform. By plotting an appropriate line on the graph, which is that, which is this line here, because that should be less than or equal to So that's that line here. And then we'll pick the minimum value, and the minimum value looks like it's going to be this one here, just by point testing really, just trial and error. So the max is at 2024 because that's going to be the lowest cost, therefore the maximum amount, if that makes any sense. So there you go, that's that. And you could also additionally work out how much that's going to cost the school, because it's going to be 40 times 20, which is 800, and 50 times 24, which is 1200, I think. So that's going to end up being £2,000 overall for them to spend. Question 14 then. A curve has the equation that and passes through 1, 0. Find the equation of the normal of the curve at A. This is a ridiculous question really to be asking at this stage. We do ydx to find the gradient, put x coordinate through, and we'll get 2. So obviously the gradient of the normal is going to be the negative reciprocal of 2, which is minus a half. Y minus b equals mx minus a. Put your numbers in, you get that. Times through it by 2, and you get that. And then make people positive, and you get that. Ridiculous 5 marks to have on the last question there. But this normal also cuts the curve in two other points, B and C. Show that the x-coordinates of the 3 points where the curve cuts where the normal cuts the curve are given by the equation that. Well, if we let y equal that, so y equals the 4x cubed minus 5x squared plus 1. Where I see a y here, so I can paste it in and call it that. And then I can expand and get that, and then tidy up, and I get exactly what the examiner wanted us to get. Show that the point B, a half, a quarter, satisfies the normal and the curve, where if you put a half through, you'll get 0.25 on both the curve and the line, therefore it must be on it. And find the coordinates of C. Well, factorise your cubic by any method. If you know factors, you can divide them in. X, and you'll end up with this: x minus 1, 2x minus 1, and 4x plus 1. Just running out of space really, I couldn't get the division on there. And you get x to equal minus a quarter, y to equal 5/8 when that's that. Therefore C is that point there, because obviously we know a half, which is there, and we know 1, which is there. So this is the only new one. So we work out what y is there, and we call C the point minus a quarter, 5/8. And that is the end of the FSMQ of June 2013. So I hope you guys have found this helpful. Please leave a like if you did. Leave your feedback down below, any questions. And yeah, a month to go now. 2 more papers for us to do. I might well do a specimen paper as well. I don't know yet. But yeah, very best of luck with that. And I hope you guys are having a wonderful day. Thanks for watching, and goodbye.